In this lesson, you'll learn to analyze quadratic functions of the form y equals a times x minus h quantity squared plus k, and write a quadratic function in the form y equals a times x minus h quantity squared plus k. How can the graph of y equals x squared be used to graph any quadratic function? A family of graphs is a group of graphs that display one or more similar characteristics. The graph of y equals x squared is called the parent graph of the family of quadratic functions. Study the graphs of y equals x squared, y equals x squared plus 2, and y equals x minus 3 quantity squared. Notice that adding a constant moves the graph up, subtracting a constant from x before squaring it moves the graph to the right. Each function above can be written in the form y equals x minus h quantity squared plus k, where hk is the vertex of the parabola and x equals h is the axis of symmetry. This is often referred to as the vertex form of a quadratic function. Recall that a translation slides a figure on the coordinate plane without changing the shape or size. As the values of h and k change, the graph of y equals a times the quantity x minus h squared plus k is the graph of y equals x squared, translated the absolute value of h units to the left if h is negative, or the absolute value of h units to the right if h is positive, and the absolute value of k units up if k is positive, or the absolute value of k units down if k is negative. Analyze y equals x minus 3 quantity squared plus 2, then draw its graph. They were nice and gave us the equation in vertex form, so we can see our vertex is at 3, 2, and the axis of symmetry is always x equals whatever the x value of the vertex was, so x equals 3. There is no number in front of the x minus 3 squared, so the graph has the same shape as the original graph of y equals x squared, but it is translated 3 units to the right and 2 units up. And that information is useful for drawing the graph. We always start by plotting the vertex and then draw in the dashed line for the axis of symmetry. They plotted 2 points on one side of the axis, such as 2, 3, and 1, 6, and then use symmetry to complete the graph. Next, we'll look at what happens when there is a coefficient multiplied in front of that x minus h squared term. How does the value of a in the general form y equals a times x minus h quantity squared plus k affect the parabola? Compare the graphs of the following functions to the parent graph of y equals x squared. When we have a, y equals 2x squared, b, y equals 1/2 x squared, c, negative 2x squared, so it's the same shape as positive 2x squared, just different direction. And the same thing for d, negative 1/2 x squared also opens down and is wide as 1/2 x squared was. All the parabolas have a vertex at the origin and an axis of symmetry of x equals 0. Notice that the graphs of y equals 2x squared and y equals 1/2 x squared are dilations of the graph y equals x squared. The graph of y equals 2x squared is narrower than the graph of y equals x squared, while the graph of y equals 1/2 x squared is wider. The graphs of y equals negative 2x squared and y equals positive 2x squared are reflections of each other over the x-axis, as are the graphs of y equals negative 1/2 x squared and positive 1/2 x squared. Changing the value of a in the equation y equals a times the quantity x minus h squared plus k can affect the direction of the opening and the shape of the graph. If a is greater than 0, the graph opens up. If a is less than 0, the graph opens down. If the absolute value of a is greater than 1, the graph is narrower than the parent function. And if a is less than 1, the graph is wider than the graph of the parent function. The absolute value of a is less than 1 means that a is a rational number between 0 and 1, such as 2/5, or a rational number between negative 1 and 0, such as negative 0.3. Here's a nice visual summary of the vertex form of a quadratic function. We can start graphing by plotting the vertex and the axis of symmetry and using symmetry to graph the parabola. If k is negative, our parabola will be translated down. If k is positive, it's translated up. If h is positive, the parabola is translated to the right, and if h is negative, it's translated to the left. Word to the wise, though, pay attention, it's x minus h. So by positive h, it's really a negative if you look at it here. And if a is positive, our parabola opens up. If a is negative, it opens down. If the absolute value of a is greater than 1, our parabola will be narrower. If the absolute value of a is less than 1, it will be wider than the parent function. Write y equals x squared plus 2x plus 4 in vertex form, then analyze the function. So we're going to have to use completing the square to put it into vertex form. I'm going to take the coefficient of x, divide by 2, and square it. 1 squared is 1. I'm going to add 1 inside the parenthesis, but then I have to subtract 1 on the outside to keep my equation balanced or equivalent to what I had. When I did my completing the square process, I had 2 divided by 2 is 1, so my completed square is x plus 1 quantity squared. 4 minus 1 is 3, so now we're in vertex form. The vertex is going to be negative 1, 3, because it's x minus h, so I had to change the sign of my 1 there. That makes my axis of symmetry x equals negative 1. There's not a numerical coefficient in front of the x plus 1, so that means a equals 1. Since a is 1, the graph has the same shape as the graph of y equals x squared, but it is translated 1 unit left and 3 units up. Of course, you could verify this by typing it into GeoGebra, but on this one they didn't actually have us draw the graph. We're done. Same directions. We want to write our function in vertex form, then analyze, and graph the function. They added something this time. We have a negative 2 as a coefficient in front of our x squared. To complete the square, we don't want a negative 2, so we need to factor that out. Negative 4 divided by negative 2 is 2. And now I'm going to take that 2 to use to complete the square. So I need to take 2 divided by 2 squared. And if I add 1 inside the parenthesis, I'm really adding a negative 2. So to keep it balanced, I need to add a positive 2 on the outside of the parenthesis. So it's equivalent to our original function. So our completed square is going to be x plus 1. We had 2 divided by 2, that was 1. And 2 plus 2 is 4. Our vertex is going to be it's x minus h, so it's going to be negative 1 comma 4. So our axis of symmetry is x equals negative 1. Since a is negative 2, our graph will open down. The a being negative 2 also means the graph is narrower than the graph of y equals x squared. Since the vertex is now at negative 1, 4, our graph is translated 1 unit to the left and 4 units up. So ideally, we should be able to draw the graph by using the vertex and the information we've gathered from the vertex form without actually using the table feature on our calculator. We can see our vertex is at negative 1, positive 4. Axis of symmetry is at x equals negative 1. It would be nice to get the y-intercept, so if we substitute in x equals 0, 0 plus 2 is 2. And they also did x equals 1 to give them another point, use symmetry, and draw in the parabola. Write an equation of the parabola whose vertex is at 1, 2, so there's our hk, and passes through the point 3, 4. So there is one x and one y value that's on our parabola. So out of the whole equation, the only thing I don't know is a. We can do that. So if we substitute in 4 for y, I don't know a. I'm going to substitute in 3 for x, 1 for h, and 2 for k. So I have 4 equals a times 3 minus 1 is 2 squared. 2 squared is 4. Subtract 2 from both sides of the equation, and I've got 2 equals 4a to 4, and we have a equals 1/2. So the equation of our parabola is y equals 1/2 times x minus h was 1 squared plus k was 2. If we type that equation into GeoGebra, we could verify that we have a parabola that opens up, has a vertex at 1, 2, passes through the point 3, 4. And here we have the summary again. As values of h and k change, the graph of y equals x minus h quantity squared plus k is the graph of y equals x squared, translated h units to the left if h is negative, or h units to the right if h is positive, k units up if k is positive, or k units down if k is negative. And if we add the a in, if a is greater than 0, the graph opens up. If it's less than 0, it opens down. If the absolute value of a is greater than 1, then the graph is narrower than the graph of y equals x squared. And if the absolute value of a is less than the 1, then the graph is wider than the graph of y equals x squared.